We're on. Okay, now, what we're going to start now, what's the date today, so you know a date? Is it, it's the 16th of November. Okay, good. The 16th of November. All right, good. Now, right. So, we're about to have the test on Chapter 6 this week. And I've made this morning, or last night, I made a pretty good, just an 8-minute test review, Chapter 6 test review. I would very strongly look at that and then study. I also put a bunch of videos on the periodic table in a playlist, so that would also be good. So I feel that we're in pretty good shape, because we have today, and then your assignments are due by Tuesday, and you can hand them in early. I'll quit today early. I'm not going to do this for a long period of time. I really have nothing left to do, unless you want me to answer questions on the material. I did a great video, very long video on Thursday that I've loaded on doing atomic radius, ionic radius. I did, what else did I do? I did electronegativity and ionization energies, and that was pretty good, although I went out of my mind because it was first period in the morning, I think, and people just didn't care. And it was hard to blame them, really. So, anyway, that's there, and that's a good one, too. So, let's begin. Now, we have studied the periodic table. We've studied a little bit of quantum mechanics. We've studied electron configuration, and we know that group 1A elements, I'm going to sound American, 1A or just one. I'm going to go back and forth between American and IUPAC. IUPAC, International Union of Pure and Applied Chemistry, that says 1 through 18 instead of 1A, 2A, and then I hate that, 1A, 2A, and then B is 3B, 1B, 2B. But let's just we'll use both, okay? Now, so 1A or 1, those are plus 1. Group 2 is plus 2. Group 3A, or group, what's 13? Yeah, 13. 3A is actually group 13. You see? Group 13, it goes 1, 2, and then 10 D elements, the transition elements, and then boron and aluminum are in group 13, right? You get it? Yes? You got to know that for the test. Yes? Okay. Those are plus 3. Carbon, group 14. That group can be plus or minus 4, correct? I'll show you that in a moment. And then nitrogen, that column, the nitrogen group, is going to be minus 3. And then it goes, oxygen is minus 2. The fluorine group is minus 1. Now, when you see the video on this chapter, I'm making the chapter 9 video now. I'm going to call it, instead of saying chemical names, I'm going to call it nomenclature. Okay? I may call it chemical names and formulas. Either way, you'll find that the way they describe the oxidation numbers is a little bizarre. But it's easy to know. How many people are comfortable with those designations? Plus 1, plus 2, plus 3, plus or minus 4, minus 3, minus 2, minus 1. Are you okay with that? Okay. Now, understand this. What is the charge of an atom in its ground state? What is the charge of an atom in its ground state? Yes, Aaron? Neutral. Neutral. That's correct. Okay? Ground state atom. Zero charge. Okay? Now, and that's okay. Now, when you combine atoms, the resulting combination has to also be neutral. Correct? Yes. Now, the reason the ground state atoms develop a charge is to be stable. We know that. They want to have a valence shell like the nearest noble gas. Okay, so let's take the easiest two. We'll take sodium +1 and chlorine -1. Correct? Stable, stable. Now, how do I combine sodium and chlorine in the smallest ratio possible so that it's a neutral particle? How many of each do I need? One of each. So I say this. Now, this is made of a cation and an anion, correct?
Yeah.
How do you say the name of the cation? Sodium, cation. Okay? How do you say the name of the anion? No. Chloride. So this is sodium and that's chloride. So what would the name of that be? Sodium chloride, correct? Am I on? Am I on? Is it there? Okay, sodium chloride, okay? That's it. That's binary nomenclature. Let's take a couple that are a little bit less direct. Let's say calcium +2 and bromine -1. What would be the formula for calcium and bromine, and how would you say the name of it? Calcium bromide, very good, excellent. What would be the formula for calcium bromide? CaBr2. Does that make perfect sense? That makes perfect sense. Calcium bromide. Now, when the book describes this, Shakbud, when the book describes it, they make an incredible big deal out of it. It's not that big of a deal. And I want you looking at the videos on nomenclature, so I've cut the homework for Chapter 9 down to just the alternate odd problems for Chapter 9. Every other odd. So 1, 5, 9, etc. Clear? You get it? Okay. Let's do one that's a little bit difficult. This is the hardest it's going to get for binary nomenclature. Are you ready? Do you think you can do this? Okay. This class is actually incredibly wide awake for first period in the morning. Except Kareem. Kareem's shaking his head no. I'm sorry to accuse you of such a thing. Okay. All right. So how about if I have aluminum and oxygen? Aluminum and oxygen. Andrew.
Al2O3.
How did you do that? Did you already do this before?
Yeah, a little with Mr. Nair.
A little bit with Mr. Nair. So you've done binary nomenclature already, some of you. Haley, is this familiar to you at all? I didn't say you had to take a quiz right now, but is some of it familiar to you? You don't know. Okay, well that's okay. You haven't, yeah, understood. Anybody, how many people it's familiar to? Raise your hand. Okay? Bisma, how about if I do this? Why don't you try the next one, okay? You ready? You ready? Okay? How about if I do this one? Al and then chlorine -1. What would that be, do you think? What would that be? Al +3, Cl -1. What do you think? Remember, may I help you think? May I be an auxiliary brain? Is that okay? Wouldn't you like to walk around with an auxiliary brain, like an extra gas tank? You know, you have Darcy's brain floating around next to you. You can like hook up into it every once in a while. It's a little creepy. Okay, so you'd say, well, I have +3 here, I have -1 here. I need 3 -1s to cancel this out because you need the smallest ratio possible. And the idea is to have a neutral particle. Okay? So let's see. How many -3s do I need altogether? How many -1s do I need to add to a +3? Bisma's trying this one. To add to a +3 in order to have a 0 charge. And I'm going to tell you how easy this is. It's just basic adding and subtracting. That's all it is. And maybe a little counting in there. So if I have -3, okay, I have -3. This is -3. I have 3 of them, right? This is -3, right? This is -3, okay? All right, this is -3, okay? Now, I have positive 3s. This giant thing is a +3, okay? I'm going to break this down, okay, into its individual components. Okay, so, oh, that didn't work out really well, did it? So let's take this one. Okay, this is positive 3, okay? How many of these do I need? How many negative ones do I need to cancel out? Let's say I need one here, that'll cancel out that one, right? And then I need one here to cancel out that one, right? Okay. I need one here to cancel out that one, right? So how many negative 3s did I use? And how many, all right, how many negative 3s did I use? I used how many altogether? How many negative 1s did I use? I'm sorry, I'm confusing you. How many negative 1s did I use altogether?
3.
I used 3 of them. So what would the formula be? How would you indicate that in a chemical formula? How would you indicate that? If I wanted to indicate 3 negative 1s, what numerical representation would I use for a 3? Do you know how to write a 3 in English? Do you? Okay, good. So what shall I help you out? So it's going to be Al, Cl, so I need 1 aluminum, that's understood, and I need 3 Cls, okay? Do you know how to write a 3 in English? How would you do that? What does it look like? Do it in the air. Do it in the air. Excellent, that's a 3. There you go. So I need 3 of these. This means I have 1 positive 3 and 3 negative 1s. Make sense? Now, how would you name that, Bisma? You say the name of the cation, right? Aluminum, right? And then you say the name of the anion with the suffix IDE. Okay? IDE. Anions always use a suffix, IDE. So give it to me, Bismuth. What's the name of that? Go ahead. You can do it. I want you to do it alone. Chlorine sounds like, no, aluminum chloride, right? Does that make sense? Okay. Shall we do another one? Let's do aluminum plus 3 and sulfur minus 2. Okay, try that one on for size. Try that one. Fatima, what do you think about that one? Aluminum plus 3 and sulfur minus 2. What do you got? Aluminum what? How would you write that? AL, go ahead. Get your, I can't read your lips. Go ahead. AL, all right, AL. AL what? AL, I know it's plus 3. The plus 3 is written right here. So what would you need? See, Andrew did that one so quickly, but I got to make sure that everybody can do this, right? So if I have, what's the least common multiple between 3 and 2? What's the least, Fatima, what's the least common multiple between 3 and 2? Fatima? Please don't anybody else answer that question. It's 6, right? Okay, good. Well, what do I multiply a 3 by to get 6? I multiply it by 2. So how many aluminums am I going to need? I'm going to need 2. Okay? How do I represent 2 aluminums? Listen carefully. I represent, Bisma, are you listening carefully? I represent the number of elements I want in the formula by putting a subscript after the symbol of the element. So it's Al2. So I put Al2. Let me repeat myself. In order to indicate the number of elements I want, I use a subscript following the symbol of the element. So I need 2 aluminums, I put Al2. The 2 goes after the element. Do you understand that? Okay. How many oxygens are you going to need, Fatima? What is it? All right. I'm sorry, how many sulfurs are you going to need, Fatima? Total, how many sulfurs are you going to need? I'm going to need 3. That's correct. I'm going to need 3 sulfurs. How do you name that? Correct. Aluminum sulfide. How many people, including Bisma back there, you're doing a very good job today, Bisma, by the way. How many people are getting a little comfortable with this? I'm not asking you to take a quiz. I'm asking you whether or not you're following me and getting comfortable. Raise your hand. Everybody, okay? All right, a little bit, okay? No, but you answered the question, Fatima. I somehow don't believe you this morning, okay? All right, you're looking for perfection, aren't you? Yeah, I know you're type. Okay. All right, so that's binary nomenclature. That's binary nomenclature. Now, let's do ternary nomenclature. How many, and then we're going to stop for today, okay? All right? All right, now, let me say one thing about binary nomenclature. Simple binary nomenclature simply uses cations from 1, 2, and 13. Right? Because those cations have only one oxidation number. They have only one oxidation number. So in other words, sodium plus 1, calcium plus 2, aluminum plus 3, magnesium plus 2, lithium plus 1. They only have one oxidation state. And and I know what you're asking me. You're asking me, so what? So who cares? What has more than one oxidation state? Well, I just want to say on the side that when we start, we just start simply. We start easy. We're easygoing about it. Okay? Because the stock system uses elements that have more than one oxidation state. And most of the transition elements have multiple oxidation states. For instance, iron plus 2, iron plus 3. This is red blood. This is red. When blood dries, it's kind of brown, isn't it? Very dark, dark brown. That's plus 2. Yes? They put this in meats, in prepared meats. They put plus 3 iron. Okay? You get it? Yeah? Copper. Copper plus 1, copper plus 2. Black, that's copper oxide. Copper 1 oxide is black. Copper 2 chloride, green. Any Americans in here, the Statue of Liberty? Copper 2 chloride, green. You get it? The transition elements have very, very unique coloring. Any artists in here? Anybody paint? Prussian blue, okay? Red ochre. You know, those all have transition elements that give them that vibrant color. Yes? Okay? So we're only using, binary and ternary are only using cations from groups 1, 2, and 3A, or 1, 2, and 13. All right, Fatima? So don't worry about it until the next day. Okay? So we're only doing binary and ternary, and they're just using cations from those 3 groups. Is that clear? So not to worry. Yes? Okay. Now, ternary is the same as binary, except there's the one rule that's different. But it's the same, really. How many people are familiar with the term sulfate? You've heard of sulfate before? Fatima, you heard the word sulfate? Okay. Nitrate, sulfate, phosphate. Okay. Yes. You've heard of those terms. Most of you have heard of those terms. Okay. Sulfate. That's a single particle. That's a single particle. That's a single particle. You don't have to memorize those. I will give you a list of them that you can use on your tests and quizzes. You never have to memorize a polyatomic ion. You will begin to memorize them because much of nomenclature, learning nomenclature, is practice. How many people know a second language? Raise your hand. Okay. How many people have learned a second language in the last 5 years? Raise your hand. How many people who learn the second language after 5 years understand that it's a lot of practice? Raise your hand. And so is learning nomenclature, it's practice. Okay? So, these are charges. These act like individual particles. TJ, are you with me? They act as individual particles. How do you say the name of an anion of a single element? For instance, fluorine -1. How would I say that name of that anion? What's the name of that anion? Anybody? Fluoride, right? Yes? So when you name a binary 2, sodium fluoride, you have to modify the anion with IDE, correct? Yes or no? Okay. When you're using a polyatomic ion, you don't modify. The name of this is sulfate. The name of this is phosphate. The name of this is nitrate. Correct? Now, what do they put in meat to make the iron in the blood +3? They put in sodium nitrite. Sodium nitrate. Na+1, NO3 -1. What would the formula be of sodium and nitrate together? How many of each do you need? Haley? How many of each do you need? A +1 and a -1. What's the total number of each that you need for the smallest ratio combination that gives the resulting particle a neutral charge? 1. What's the name of that particle? Anybody? Sodium nitrate. That's what they put in meat. Yeah, I know, it's disgusting. You cook that at high temperatures with the protein, you produce nitrosamines, which are carcinogenic. Anybody ever hear of bacon? I know that we're in a Muslim country, but there are many expats here that eat bacon. They love bacon, they smell bacon, and they turn into crazy dogs. Okay? A commercial about bacon? Bacon, bacon, bacon. Love bacon. Okay. Yeah. So, when you do that at the high temperatures on the stove, you produce a carcinogenic compound called nitrosamines. It's more healthy to cook your bacon in a microwave. Okay. Kareem, do you have a question?
What's the point of the 3 under the nitrogen?
Here?
Yeah.
That's the particle. That particle is a specific molecular particle that's made of 1 nitrogen and 3 oxygens. You don't break it down. It's that particle goes around. You get it? It's that particle. You don't mess with it. Clear? Are you sure? Are you positive? Excellent. Bones. How many people have ever heard of human bones? Raise your hand. Okay, Haley is definitely not here today. Her brain is wandering around the hallways. I may send Professor Houlihan around to find her brain. Excellent. Did you hear bones before? Now she's annoyed at me completely. That poker face. I'm starting to tell. She's getting a little smile there. Excellent. Now, bones are made of what? What are bones made of? Calcium. Is that it? Okay. Bones are made of, shall I erase this? Bones are made of calcium. What's the charge of calcium? What's the charge of calcium? +2. They're made of calcium and phosphate. I want to know the name when you combine calcium and phosphate. Write this down right now. This is a great quiz. I want to know the name of bones when you combine calcium and phosphate, and I want to know the chemical formula for the resulting chemical. Okay? Try it. Do it now. Do it. Do it now. Aaron, do you have it? All right, I need to know bones. What's the chemical formula and name for bone? Bone is made of calcium and phosphate. I want to know calcium and phosphate. What is bone? What's the chemical formula and chemical name? Anybody got it? The name's easy. What do you call it? Calcium phosphate. Andrew, excellent. Excellent. Augustina, do you know the formula yet? Fatima, do you got it yet? Are you looking that up on the web? You are, aren't you? I want you. I know. I want you to figure it out. That's very good, though. By the way, okay. Now that you know it, it's irrelevant. But all right. So it's Fatima. You got to go like this: +2 phosphate -3. So you've got to combine. How many of each do you need? You see 2 and 3, you automatically think what? 6, right? When you see 2 and 3 in nomenclature, you're automatically thinking 6. Automatically. I see 2 and 3, I don't see 2 and 3. I see 2 and 3, I see 6. Clear? Yes or no? Andrew?
Would it be Ca3PO8? PO2.
You use parentheses. When you're, listen carefully. I hope you look at this video because it's explaining everything. Bisma, when you are indicating the presence of more than one polyatomic ion. Polyatomic ion. You use parentheses. If you're only having one polyatomic ion, like the last one was sodium nitrate. Right? Sodium nitrate. I only had one polyatomic ion there, didn't I? Right? Do you need parentheses? No. That would be wrong. Clear? You have to use parentheses if you have more than one. You clear? Do you understand? Now, if you want to kind of like use a little trick, does everybody know the difference between an odd number and an even number? Oh, thank God you do. Okay? We would have a lot of work to do today if you didn't. Well, if this is an odd and an even number, if that's an odd and an even number, you know what you can do? Crisscross. Brain dead. Yeah, you get it? Just crisscross. Shall I give you a few like that? You ready? Okay. How about aluminum? And aluminum and sulfate. Aluminum and sulfate. Do this one. Aluminum and sulfate. What's the name? Oh, we already said the name of this, calcium phosphate. What would the name of aluminum and sulfate be? Aluminum sulfate, right? Easy? No modification, dead easy, right? So what would the formula be, Fatima? Don't look it up on the web. For aluminum sulfate. We're doing that crisscrossing thing. You can do that crisscrossing thing. What would the formula be for aluminum sulfate? Anybody? What would it be?
Al2.
Al2, good. I like it. Al2. No. Not sulfide, sulfate. Remember I wrote it on the board what sulfate was?
Oh,
SO4 -2 charge.
SO4 is greater than C.
Yes, exactly. So it would be Al2 SO4 3. Okay. Look up on the web, Fatima. Magnesium sulfate. What is magnesium sulfate? What's the name for magnesium sulfate, and when would it be used? Write the formula for magnesium sulfate, everybody. Write the formula for the chemical magnesium sulfate. Aaron.
MgSO4.
Yeah, thank you very much. That you looked up on the web. And what's the nickname of that? What's magnesium sulfate called, and what is it used for? Put in uses for MgSO4.
Ammonium or
No, it's magnesium sulfate. Yes.
it's used as a laxative.
Inorganic salt.
Magnesium sulfate. Anybody?
Drying agent.
Drying agent. Epsom salts. Is that what it says? Epsom salts? Yeah. Epsom. It can be used as a laxative. Magnesium. You can buy magnesium citrate. That's old folks use that. That citrate is a polyatomic ion. That's all it is. Magnesium citrate can be used. So the magnesium ion can be used as a laxative. Yeah. Magnesium hydroxide. right? So magnesium sulfate, MgSO4. That's MgSO4. Am I on target there? Okay. MgSO4, magnesium sulfate. Let's do one more and then quit for the day. Is that okay? And we'll do other things, all right? All right, now, how many people have ever heard of bleach?
Oh yeah.
Kareem's not here. He's like hanging out with Haley in the hallway. Okay. All right. So, so what is it? Sodium and what? What is the what is the polyatomic ion that makes bleach? It's sodium and something. Sodium what?
Chloride.
No. That would be too easy. Shall I write the name down? Yeah, I'll write the name down.
Sodium hydroxide.
Who said that? Who said that? There he is, Mr. IKEA. Yeah, I like it. I'm telling you, the man's going for management. I like it. I like it, man, I'll tell you. The big guy's doing it. What do you got there, big guy?
Sodium hydroxide.
No, sodium hydroxide, no. It can be used, I suppose, but that would be a little harsh. Your clothes might actually disappear as a result of that. Yes?
Sodium hypochlorite.
Sodium hypochlorite, that's right. Sodium hypochlorite. So all you need to know, right, is the formula for hypochlorite, right? Right? And the charge, right? And you can just look that up, right? Aaron, you have it?
Yeah.
What is it?
NaClO.
Yeah, but I want, no, not Ci, no. What is hypochlorite? What's the polyatomic ion hypochlorite?
CiO.
No, it's not an I. It's not Ci. No, I don't want to know sodium. I want to know hypochlorite. Can you just? No, it's not an. Why are you saying I? That's an L. Oh yeah, yeah, and you're so magnificent, Michael. Absolutely. They called him, Linus Pauling, right? Okay, ClO. That's it. -1 charge. Okay. I'll give you a hint. I'll give you a little lesson in polyatomic ions. ClO2, ClO3, ClO4, all -1. Are you ready? Hypochlorite, chlorite, chlorate, perchlorate. Easy? You don't have to memorize it, but it makes sense, doesn't it? I mean, it's just prefixes and suffixes, right? So it's hypochlorite, chlorite, chlorate, perchlorate. These are all -1 charged. All -1 charged. Are you ready? Hypochlorite, chlorite, chlorate, perchlorate. Hypobromate. Hypobromite, 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 bromite, bromate, perbromate. Hypofluorite, hypofluorite, ITE, hypofluorite, fluorite, fluorate, perfluorate. Hypoiodite, kind of fun to say. Hypoiodite, hypoiodite, hypoiodite. Say it together. Hypoiodite, iodite, iodate, periodate. Easy? Dead easy. Yes or no? In about 10 minutes, those of you who really care, I mean, I could teach you probably 150 polyatomic ions, and you'd only have to memorize like 5. No, I'm not doing it. No, I'm not doing it. Yeah, it's really that easy. Okay, but I give you a list, okay, of like, I don't know, 40 or 50. You don't have to memorize them. Easy? Now, again, what I'm giving you, you don't have, there's no guessing in terms of what the oxidation number is. Remember, this is an oxidation number. So I could write, if I give you a cation, magnesium. What's magnesium? Do this one and then we're done. Magnesium, you ready? Write this down. What's the formula for? Magnesium perfluorate. Magnesium perfluorate. Magnesium perfluorate. Magnesium perfluorate. Magnesium perfluorate. Now, I didn't say magnesium fluoride. Magnesium fluoride is what? MgF2, right? I said magnesium perfluorate. So this is it right here, right? -1, right? So it's going to be magnesium plus 2 perfluorate. So how would you write the formula for magnesium perfluorate? Bismuth. You with me? You sure? So how would I write that formula? You can do it. I need 2 of these, right? Parentheses. You put down the Mg. Parentheses. FO2, FO4, and then a 2. Easy?
Yeah.
Get it? MgFO4 2. That's how I would say it. MgFO4 2. MgFO4, take a breath, 2. MgFO4, breath, 2. MgFO4, the parentheses is the breath, 2. MgFO4, 2. Clear? Got it? Binary and ternary nomenclature. Now we only have 3 left. We'll only do, we did 2 at a time today. We'll take a day and we're only going to do 1 at a time from here on in. And then quizzes, we're going to have a ton of quizzes. So you can expect quizzes for the next 2 weeks. Clear? Until break. Well, our mini break, our December break. Early December break. Okay?